All right, today we're going to talk about systems of equations, and we're going to talk about the substitution method. This is one of three methods in order to solve systems of equations, and this one is exactly as it states. It's substitution method. So we are going to get one of the equations equal to one of the variables, either x or y. If you see equation number 1 here, we already have y by itself, so we'll use that one. So we'll call this equation 1. We'll go with equation 2 down here. So what substitution method is asking you to do is to take the equation y equals. So y equals 3x minus 2. We're going to take what it equals, and we're going to substitute it in for the y in the second equation. When we do that, our second equation now looks like 2x plus 3x minus 2 equals 8. We have taken what y equals and substituted it in the second equation. We do this because now if we see this new equation, we have only x variables in it. We know how to solve an equation with one variable now. Now we simplify. We add our like terms, so I have a 2x and a 3x. That gives me a 5x. Then I have minus 2 equals 8. From here we add 2 and divide by 5, leaving our x equal to 2. Now, we want to solve a system of equation. The idea is that a system of equation is a point in which both lines intersect. So to get a point, I need an x value and a y value. I found my x value. We got x equals 2. I need my y value. To do this, we take our x value, we plug it into either equation, either the first or second equation, and solve for y. I'll go to the first equation just because. So y equals 3 times x we know is 2. So replace x with 2. Minus 2. And we simplify. So y equals 6 minus 2, and y equals 4. Now that we have our x and our y value, our answer to the system is the coordinate 2, 4. Let's take a look at another example together. In this example, our two equations, we have 1 and 2. The difference here is that one of the equations is not set equal to y or x. In our first example, we had y equals something. So we have to do a little prep work here. You need to decide, either in equation 1 or 2, which one you're going to get a variable alone in. I would say equation 1 is easiest, because the y is already pretty much by itself. We just need to subtract 2x. So to change this equation, I'm just going to subtract 2x from both sides. And I now have y equals negative 2x minus 5, which is exactly what I want. In substitution, you need to get an equation equal to one of the variables, either a y equals something or an x equals something. So now that I have y equals something, I can take that something and plug it into the y in the second equation. When I do that, this is what I get for the second. 3x plus 5 times negative 2x minus 5 equals negative 4. And as you can see, my second equation now only has x variables in it, which is exactly what I want. So from here, I simplify. 3x, distribute the 5, minus 10x, minus 25 equals negative 4. Continue to simplify by adding like terms. I have a 3x minus 10x, which is negative 7x. Minus 25 equals negative 4. We add 25 to both sides and divide by negative 7, leaving us with x equals negative 3. Now we have our x coordinate, but we always need a y coordinate. So in order to get the y coordinate, you can plug the x value into either one of the original equations. Again, I'm just going to pick equation number 1. So in equation number 1, I now have 2 times the x value I know is negative 3 plus y equals negative 5. Simplifying, I get negative 6 plus y equals negative 5. Adding 6, y equals 1. Therefore, my intersection for this system, my answer, is negative 3, 1. Now we've done two examples on our own. Why don't you try this one out by yourself?